So in this problem, we have two waves, and I know I didn't draw it to scale, I apologize, but you should see on your problem, wherever you're sourcing this problem, you can see the waves, and we have one whose wavelength is really, really short, and it's oscillating at really high amplitudes, where the one is kind of taking its time. And we are asked to solve a couple of problems here. What is the amplitude of each wave? What's the frequency? And then what's the period of the wave? Okay, so just some basic simple harmonic motion questions. How do we go about it? So wave A is the red wave, and wave B is the blue wave. And we're asked about the amplitude. And the amplitude is how high does the wave go before it's going to crash down? What's the maximum height? Well, notice for the red wave, we go about 1, 2, and about a half. Okay, so it peaks at 2.5 and goes all the way down to negative 2.5. So for wave A, we're going to say that the amplitude is 2.5. And the units here, we'll say meters. Okay, this is in meters. Okay, so 2.5 meters. Okay, for B, it's going a lot further. How far? Let's count. So we go up 1, 2, 3, about 3.5. So the amplitude of wave B is about 3.5 meters. Okay, so that's kind of easy. Now we're asked about frequency. And remember that frequency asks you how many oscillations per unit time, or specifically how many oscillations per second, and that's in hertz, right? So how much of something do you do per unit second, okay? So the frequency is how many oscillations. Okay, so for wave A, let's think about it. So in 1 second, we go to a max height, right? So we go 1, and then, so this is this amount of space that we've gone. So to complete the wavelength, we go 1, 2, for every 2 seconds, we complete the first half, 3, 4. So the frequency, we only complete 1/4 of the wave cycle in a second. So we're gonna call this, for the frequency, 0.5 or 0.25 hertz, okay? Now, for the blue wave, how far do we move in 1 second? Well, we go all the way from a peak all the way down to a bottoming out. And to get back to here, we just need to go another second. So in 1 second, we complete half of a wave oscillation. Therefore, the frequency, or the amount of oscillations per second, is a half, which is 0.5 hertz. Now the period gets a little easier, okay? It says how much time to complete one oscillation. Let's look at A. How long does it take us to complete one full oscillation? Well, notice that at t equals 0, we start at 0. We go up, down completes at 3, and we get back up to this section where we would go up again at 4. So the period of wave A is 4 seconds. Right? It takes us 4 seconds to complete a full wave oscillation until we repeat what we got back here. So right here we would have characteristic movement starting from here. It's kind of like a loop, right? For wave B, what's the period here? Well, notice we are asked how long does it take to do one wave? And we start at a very high point, so we need to find the next point of which we get to a very high point, or the highest point, the peak in the positive direction. So go all the way down to at 1 second, and at the second second, we're back to where we started. So we're gonna say that the period here is 2 seconds, right? It takes us 2 seconds to complete a full oscillation before, again, we go down and up again, which would bring us to 4 seconds, right? So that's the relevant information, the amplitudes, the frequencies, and the periods of these two respective functions. Hope you guys enjoyed. If you did and found something helpful today, please subscribe, comment, and like. I would greatly appreciate it. I hope you have a wonderful day. Bye-bye.